Hello guys, welcome to the Learn Board. I have created this video to explain about the dynamic braking of a DC motor. You all know that when we connect a DC voltage supply to a DC motor, the motor axle rotates. Have you ever tried connecting a small bulb to a DC motor like in this figure and rotating the motor axle? If we rotate the motor axle fast enough, you can notice the bulb is light up bit. Actually, in that case, the motor acts like a generator. When we disconnect the supply to the motor will rotate freely for a while due to the inertia. When the motor axle is rotating freely without a supply, the motor acts like a generator. That means soon after we disconnect the supply to the motor, it becomes a generator. In the case of dynamic braking, we connect the load across the motor terminal like in here, soon after disconnecting the supply. Then there will be a current flow through the load and it converts the kinetic energy of the motor to another form. This energy absorption by this load helps to stop the motor faster than the freewheel stop. Resistors are commonly used in most of the time as the load for dynamic braking. When we select a small value for the resistor, it increases the braking amount since the current flow is high. However, higher current flow might cause damages to the motor. On the other hand, if the resistor value is high, the braking effect is low. So we need to be careful when we select a resistor, especially for a large DC motor. For a small DC motor, using a very small value resistance like short circuiting would not cause any damages. Now I am going to conduct a small experiment to show the behavior of dynamic braking.
Now you can practically visualize this dynamic braking situation. Here we have a DC motor and from this side we have a battery pack. So from here we make the connection of ground and from this bus we can make the connection of positive voltage. In the first case I'll check the freewheel stop of the motor. So now I am connecting the motor terminal. Because of the power supply, now motor is rotating. Now I am going to switch off the supply to the motor. In this case, now I am going to do the dynamic braking. Again I am now connecting the motor supply. Now motor is rotating as similar to the earlier case. In this case, when I remove this motor supply, I am going to connect it to the ground. That means I am short circuit the terminal of the motor when I soon after the disconnection. Let's observe.
Hope you have noticed the difference of stopping time of the two cases. In the case of freewheel stop, the motor took 3.33 seconds. In contrast, the motor took only 2.66 seconds when we applied the dynamic braking. The use of dynamic braking can considerably reduce the stopping time of the motor. So dynamic braking is important for precise control of robots. For example, dynamic braking is useful for sudden stopping of a moving mobile robot. In this video, I have explained about the dynamic braking of a DC motor and demonstrated the behavior using a simple experiment. Thank you for watching this video. Please subscribe our channel Learn What to learn robotic related stuff.